Welcome to the Pharmacy Masterclass based on calculations training for displacement volumes. What I'm going to do today is just give you a little bit of an introduction as to how the Masterclass works and what's involved. So first of all, what happens is you will receive a PDF calculations training workbook. And this unique workbook is linked to a catalogue of YouTube training videos which I've made. Now, my methodology of training is that what I tend to do is I highlight one specific topic. So, for example, in this calculations training scenario, it's based on displacement volumes. And what we tend to do with the learner is really get a good understanding of what the methodology is behind this topic of calculations, how the questions can be worded in different ways to gain an understanding of how we can break those questions down to build out and extract which information it is that we actually need, how we build a game plan to tackle those questions, and ultimately how we get to the answer. By doing this, what the learner finds is that when they go into the exam, if the topic question is given in a different way, if it's a very wordy question, no matter really how it's given to them, they're able to utilize these skills that they've learned to then break that question down and answer it. And I've been training pre-regs like this for the last 22 years, and it's been a fantastic success. It always works. So really, the idea is that not to practice mixed exam papers, it's to focus on one specific topic at a time, gain mastery of that topic, and be repetitious. Really do it again and again and again, so that when we get to the exam, our brain can then really start understanding what it is it's been learning and just apply that knowledge. So let's have a look at the workbook first of all. So the way the workbook's laid out is that the workbook is uniquely linked to your email address. So it's the email address that you use to log into YouTube. So for example, here in the introduction, you can see a YouTube link at the bottom of the page. When you click on this YouTube link, it will then open up a private tutorial video. And as long as you're logged in with your own email address, which is linked to the book, you will then be able to watch the video. So let's have a look at the first question. So this workbook, Displacement Volume, consists of 50 past exam papers. And those 50 past exam papers have all got a unique YouTube link embedded on that page, which takes you to my tutorial video, which isn't just about, oh, here's the answer. It's about understanding. The video shows you what the methodology is involved, what the tips are in terms of how to approach the question, what the learning points are, and really making sure that you're actually improving the way you're doing calculations and that you're mastering it. So a good idea now might be to pause this video and read through this question. Once you've read through this question, then press play and you'll be able to see an example of how this video actually works. So I'm going to click on this link over here, and then the next step is the video is going to play. Right, so the answer to this question is 1.6 mils. Now let's get an understanding of how we're going to go about tackling this and what process we're going to use for calculation questions. For people who've completed workbook 1 and 2 on calculations, you'll be familiar with the 3-stage process that I tend to teach whenever we encounter a calculations question. So let's start from the very beginning. Stage 1 is where we're going to look at the calculation question and we're actually going to read it comfortably from the beginning to the end. No matter how silly that statement sounds, you'll be surprised by how many students start reading a calculation question and they'll just jump to conclusions halfway through, see something that they think, oh yeah, I know that's what it wants, and they'll just start going off on a tangent doing the calculation, when without reading the full question. And that's the trick. The trick is that if you read the full question first of all in stage 1, you'll get a really good understanding of what's going on. So avoid jumping to conclusions, avoid looking for what you want to look for, just read through the question to gain an understanding. Stage 2 in the question is going to be to categorize that question. So I'd like you to look at that question and say, okay, here's my calculations checklist. which you should have got from me. If you haven't got the calculation checklist, then just get in touch and I'll fire that across to you. And you should be categorizing which category this falls into. So this calculation here is a displacement volume calculation. And what is the purpose of stage 2? Well, the purpose of stage 2 is by categorizing the question, your brain can use what's called active recall. It can think about all the times you've done the calculation questions in that category and what were the variations in those questions when you did them. So what that means is, what were the different ways that they asked that question? What was the different pitfalls that you came across when you were doing displacement volume calculations? So in the introduction, I talked to you about the different ways that displacement volume calculation questions can be asked and what they can ask from you. So for example, in this question here in front of us, they're asking us to calculate the displacement volume for a quantity of specific powder. Another way they could have worded the displacement volume calculation question is they could have said, calculate the final concentration of solution, or calculate the dose that needs to be administered from the final concentration of solution. So there's many different ways that they can ask it, and what are we trying to do? We're trying to practice every single way that we've come across, or we can come across, and develop a methodology to tackle them. So that's the purpose of stage 2. Stage 3 is to then highlight out any key bits of information that you want to remind yourself of at the end of the question to double check. So for example, if it said, round the answer to 2 decimal places, then you're going to write that in a little box over here, so that at the end of the question you can look up at your box and say, right, have I met what I needed to? Have I rounded it to 2 decimal places? Did I actually give it in grams what they wanted, or is my answer still in milligrams? So that's the importance of the little box up here that I tend to do sometimes. So for this question here in front of us, we can see that there's no rounding required. They haven't asked us to round it to anything. So I'm not going to bother with the little box because I don't need to put anything in there. But now what I'm going to ask you to do is I'm going to ask you to visualize the question. Now this is key, because the best way to tackle displacement questions is to visualize what it is that's actually going on. And I use this procedure when I teach infusion rates, when I teach dilutions, and it works like a charm. It's a really, really good method of tackling questions. So let's have a go. You can visualize it in your mind, or you can do it on paper. For me, I always map it out on paper, and when I start with pre-regs, in the first 3 to 4 months of their 12-month placement, we always do everything on paper, and then slowly some of them develop and say, look, they're happy to do it in their head, which is great, but I always start on paper first. So we're going to look here, and it says, in order to produce 100 mils of mixture containing 250 milligrams in each 5 ml dose, so they made a mixture, and it was 100 mils in final volume, and it had a concentration of 250 milligram in 5 ml. The pharmacist is required to add 60 mils of water to the powder. So we had a powder over here, and then the pharmacist added a volume of 68 ml. Calculate the displacement volume for a quantity of powder equivalent to 250 milligrams. So now we've put down the facts. All we've done is we've not made anything up. We've looked at the question and we've put together a little visual representation of what's going on. And please, for the first maybe 15 questions in this workbook, or 20 questions, I'd like you to do this method, just so you start getting a visual representation of what's going on. In order to develop with this workbook, try and follow the steps that I'm teaching you. The reason being because I've been teaching this for 20 odd years, and it consistently helps students to understand what it is that's going on in the question, so that then they can tackle it a lot better. So let's take a look now. Now that we've done that step and we've visualized what's going on, the next step I'd like you to do is I'd like you to write down your displacement volume formula. So whenever you're doing a displacement volume calculation, you're going to use active recall and you're going to pull out your formula. And your formula can be written in different ways, but the most common ways to write it is like this: final volume FV equals the displaced volume plus the added volume. Okay, Now, I want you to learn this formula. Just like you know paracetamol is 1 to 2 tablets 4 times a day. Just like you know ibuprofen has to be taken with food. Just like you know that beta blockers have to be carefully given with people who are asthmatic. It's innate behaviour. You're going to have to learn this. So if you've got workbook 1, you're familiar with the formulas that I said you had to learn for workbook 1 and workbook 2. For workbook 3, this is the main formula that we need to know and we need to learn. So I want you to write this out and stick it on your dashboard in your car if you drive to work every day and back. I want you to stick it in your bedroom, above your bed, on the ceiling, whatever, so that you start learning this and it becomes innate behaviour. So this formula here, when you look at it, let's have a look at why I want you to learn it. Because when you look at this diagram above, you're going to put in where these pieces go. This formula is referring to mils. It's saying final volume in mils equals the displacement volume in mils plus the added volume in mils. So remember that the units are always the same. So where's the final volume? The final volume is what you made up over here. So you can see we've got that in mils here. It's been given to us, the final volume, 100 mil. The displaced volume is here, and we've not been given that so far. So the displaced volume is a fancy way of saying our powder here, how many mils is that going to take up over here when we add the volume of mixture. So we don't know that at the moment. Now the added volume in mils is always going to be up here in the picture. It's how many mils are added to product A to make product B. So that's how I will always refer to it, A and B. So you need to get used to understanding this formula and where it goes in. Now let's take a look at rearranging this formula. So I want to talk to you about this. Okay, so rearranging formulas. If I said to you that 6 equals 4 plus 2. 6 is the final volume, 4 is the displaced volume, and 2 is the actual volume. You can rearrange that, can't you? How can you rearrange it? Well, you could move, let me just highlight and show you. You could move this plus 2 here to the other side. So you could move it to this side. And you could say that 6 take away 2 equals 4. So do you see what I did there? I've moved the plus 2 to this side of the equation, and it's saying the same thing, that 6 equals 4 plus 2, 6 take away 2 is 4. It's achieving the same thing. So the final volume was where 6 is. The minus 2 is where the added volume was, the 2. So I'm going to put final volume minus added volume equals 4, where the displacement volume is. What I'm trying to do is just get into your head that when you've got a formula like this, you can change that formula around to get another parameter in there. So if I wanted to know what the displacement volume was, I can move the added volume to the other side. So final volume minus added volume equals displaced volume. So now let's have a look at why that's important. That's important because if you start putting in the values from the diagram, the final volume was 100 mils. The added volume was 68 mils. So if you do 100 minus 68, that gives you 32 mils, which is your displaced volume. That's the amount of volume that the powder's going to take up in here. So out of this 100 mil, 32 mils is the powder. The remaining is 68 mils that was added up here, the added volume. So that gives you an understanding now that the final volume is the added volume plus the displacement volume over here. So now that we've calculated this displaced volume, what we can do is we can say, look, the concentration over here is 250 milligram in every 5 mil. So what's the concentration in the final volume? 100 mil. So I'm just going to take a look at the screen to make sure you can see it. I haven't even had a look actually. My screensaver's just come on. Sorry about this, guys. Let's have a look. Yep, you can, which is excellent. I'm just going to scroll this up a little bit. So what we're going to do is we're going to take the concentration now, 250 milligrams in 5 mil. And what we're going to say is that what is the concentration, what is the number of milligrams in the final volume of 100 mil, because that's our final volume. Well, to go from 5 to 100 over here, we say 5 times 20 is 100. So we're going to multiply the 250 milligrams by 20. And that's going to give us an answer of 5,000 milligrams in 100 mil. So there's two ways to work this out, of using the factorization method, where you say I can see how we can go from this volume here to this volume here by multiplication, or what some people do, which I tend to do a lot of with students, is I teach them to go to 1 milligram, because it's not always easy to see what factor it is you need to multiply or divide by. Excuse me. So what I tend to teach students is I say to them, okay, you need to know how many milligrams there are in 100 mil. So why not go from 5 mil down to 1 mil and then work your way back up? So let me show you. So if I wrote 1 mil here and I said to go from 5 mil to 1 mil, you have to divide it by 5, correct? So on the other side, you have to do the same thing, divide it by 5. So 250 divided by 5 is the number of milligrams in 1 mil. Now I'll say to you, okay, to go from 1 mil to 100 mil, you have to times by 100. So we're building it back up to 100 mil. So do you see what we did? We went from 5 mil to 1 mil, and 1 mil to 100 mil, because it's easy to do that. You divide this number always by itself to break it down to 1 unit. So if we're timesing this side by 100, we're going to times that side by 100. So let's do that now. Times by 100. So 250 divided by 5 times by 100 will tell us the number of milligrams in 100 mil. And that is the answer, 5,000. 5,000 milligram in 100 mil. So that's the number of milligrams of powder that is in the final solution B up here. So now that we've calculated the number of milligrams that's in the final solution, what we can say is that 5,000 milligrams displaces 32 mils. Because we know that in here the displacement volume is 32 mils, so the powder is taking up 32 mils of space. And we calculated how much powder's in this mixture by taking the concentration and working it out for the final volume. So if we know that 5,000 milligram displaces 32 mil, the question's asking us how much will 250 milligrams displace. So the question's asking us 250 milligram displaces how many mils. So again, somebody could say to you, well, how do you go from 5,000 to 250? Whatever factor that is that you divide 5,000 by to get that, you have to divide 32 by the same amount. Now it's difficult to see that factor. So again, what I always advise is go down to 1 milligram first. So 5,000 divided by itself, which is 5,000, will give me 1 milligram. So I can on this side divide the 32 by the same number. Because remember, when you're dealing with equations or factors, whatever you do to one side you must do to the other. So this is going to be 32 divided by 5,000. That's how many mils are in 1 milligram. And I want to know 250, don't I? So what am I going to do? I'm going to multiply now by 250 to get 250 milligram. So I'm going to do on this side 32 divided by 5,000 multiplied by 250. So what we're doing essentially is we're saying, look, when you need to work out a number, break it down to 1 milligram and build it back up to whatever number you want, and do the same on the other side. By doing that, when you put this in your calculator, 32 divided by 5,000 times 250, you'll get 1.6 mil, which is your answer. So I know this looks a little long-winded, but don't worry. This is just the first step. This is just the first question that we're doing, and I've done it deliberately with you really, really slowly. And I've explained every little step as we've gone through it, because I really want you to get an understanding of what's going on. The key takeaways from this question really are that this formula here, final volume minus displaced volume plus added volume, can be rearranged. Okay? You need to learn that formula, because whenever you have a displacement volume calculation, you're going to need to know it. You're going to have to start visualizing the questions for displacement volumes when you're doing them. So I want you to start visualizing them and drawing them out so it makes sense. Then I want you to apply this from your formula. Where does it go on the picture? Once you've done that, you'll be able to then work out which way around you need to use the formula, and you can then work through the question. This is really, really good method to use, because when you get to wordier questions and you're familiar and you've developed this technique, you're going to be in a really good place to tackle them. So this workbook's going to start off with this sort of a procedure, and then we're going to take a look at different types of displacement volume calculations and work our way up. Right, so I hope you found this introduction useful, to give you a bit of an understanding of what the Pharmacy Masterclass in the calculation element actually involves. So do please log on to my website. It's www.pharmacymasterclass.com, and on the website you'll be able to gain, again, a bit of an understanding as to what it is that my training is all about. It's not about taking any shortcuts, it's not about wasting time or any crash courses. It's just about, really, again, like it says on the website, it's targeted, it's focused, and it's proven teaching. So the current classes that I've got listed at this point in time, as of Wednesday the 28th of September 2022, is I've got the full health economics calculations masterclass, and that involves drug cost saving, it involves incremental cost effectiveness ratios, private prescription cost calculation training, medication synchronization training is included, and there's a whole host of other things like NNTs and NNH, number needed to treat, number needed to harm. So there's 80 past exam paper questions in there with 80 plus video tutorials to teach you the methodology behind that. The displacement volume one is what I talked about today, which has got 50 past paper exam questions in, plus 50 plus videos. And then there's the moles calculation masterclass training package that went up about a week ago, and that consists of 80 past paper exam questions and all the different types of questions that you might encounter to do in the category of moles, and it's got 80 plus training videos, which is absolutely amazing. There is currently still on offer the OTC full revision guide plus exam questions, and that's a physical copy that's posted out to you. And there will also be an online OTC quiz, revision quiz, coming soon on the website. Please keep an eye on the website, as there is much, much more to come. Hopefully over the coming year we'll be able to see classes for infusion rates, dilutions, concentrations, and much, much more. I'll also be including things like the BNF masterclasses, which will be chapter by chapter focused training, including past paper exam questions, MEP masterclass, and also some lifestyle classes on things like time management and productivity. Thank you for taking your time out to watch this video today. If you've got any questions, just drop me an email. It's available on my website. If you like the video, please give it a thumbs up and subscribe. Share my website with your friends. You never know, it may benefit somebody out there.